Hello children, today we will discuss group 16 elements of oxygen family, also known as chalcogens. So in this group, oxygen, sulfur, selenium, tellurium and polonium are placed. Group number 16 elements. General characteristics of these elements. First is electronic configuration. So the outermost shell configuration of these all elements of this particular group is ns2np4. Outermost shell with total 6 electrons. As you can see here, oxygen with 2s2 2p4, sulfur with 3s2 3p4 and so on. Then physical properties of group 16 elements. And the first is physical state and molecular structure. So in 16 group elements, oxygen is gas while all other elements are solid at ordinary temperature. And this is because oxygen exists as a diatomic molecules while rest of the elements are present in the form of complex molecules like S8. So due to this complex structure of molecules, these rest all other elements except oxygen is present in solid state. Okay, so oxygen can form p pi multiple bonds, and that is why diatomic molecule, and this diatomic molecule is having weak intermolecular van der Waals force of attractions. Okay, whereas rest all other elements of this group not able to form p pi multiple bonds due to the large atomic size. Therefore, these elements do not occur as diatomic molecules and forming a complex molecular structure as in the case of S8, and that is why they are present in solid state due to comparatively stronger van der Waals force of attraction. Then atomic and ionic radius. So the atomic and ionic radius of this group elements is smaller than group 15 elements. This is smaller in size due to the effective nuclear charge, more effective nuclear charge, and atomic and ionic radii of group 16 elements increases on moving down the group. Why? Because new electron shell at each successive element increases on moving down the group. The next property, melting and boiling points. So these elements are having regular increase in melting and boiling point from up to down in the group. Okay, but exceptionally the melting point of polonium and polonium are smaller than those of selenium. So melting point increases from up to down in group due to increase in van der Waals force of attraction, but the melting point of polonium as compared to that of selenium is lesser due to inert pair effect. And you know that what is inert pair effect? Inertness of the electrons of an s shell to take part in the bonding. Okay, so this is known as inert pair effect. So from up to down, this inert pair effect increases, and that is why the melting point of polonium is lesser than selenium. Then ionization enthalpy or ionization energy. So these elements are having higher annihilation enthalpy than the group number 15 elements, and this decreases from up to down in the group. Okay, students. Then electronegativity. Elements are having a higher electronegativity than group number 15 elements, and oxygen is the second element after the fluorine, most electronegative element. Then electron gain enthalpy, it is also again more than group number 15 elements, and their high electron gain enthalpy is due to the high electronegativities of the elements. Then oxidation states. Oxygen shows a number of different type of oxidation states, but the most common is -2. Okay, with fluorine, in the compounds with fluorine, oxygen is showing positive oxidation state. Okay, but sulfur and all other elements are showing number of different oxidation states, higher oxidation states, and these oxidation states are due to the vacant d orbitals which are present in these elements from sulfur to next higher elements. But oxygen is not having d orbitals, that is why it is showing up to 2 oxidation state, +2 highest oxidation state. Next property is catenation. Oxygen showing a little tendency towards catenation, but sulfur is showing greater tendency towards catenation and links up several atoms in the form of chains. Allotropy. All the elements of group 16 show allotropy, in which an element is exist in number of different physical forms. For example, sulfur is present in different allotropic forms known as homocyclic catena S and sulfur, unstable small SN molecules. So these are the allotropic forms of sulfur. Then chemical properties of group 16 elements. Hydrides. Group 16 elements are forming H2M type of hydrides, and in these hydrides M can be oxygen, sulfur, tellurium or polonium. For example, H2O. Oxygen is forming hydride which is known as H2O, and of sulfur the hydride is H2S. These hydrides are having angular structure as present in water molecule, angular structure with central atom sp3 hybridization. Okay, students. The next compound of sulfur are halides. So in these compounds, different elements of this group number 16 are forming different type of halides. The compounds of oxygen with fluorine are called fluorides because fluorine is more electronegative than oxygen. Okay, sulfur is forming these different 4 types of halides: monohalides with 1:1 ratio, dihalides, tetrahalides and hexahalides. The next type of compound of this group is oxides. So the group 16 elements are forming monooxides, dioxides and trioxides. As you can see, sulfur is forming dioxide, and in this dioxide SO2 central atom sulfur is showing sp2 hybridization. This is the structure. In this structure, S and O pi bond is of 2 types. One pi bond is p pi pi bond, and the next pi bond is d pi p pi bond. So in this pi bond, d orbital of sulfur, anhybrid d orbital of sulfur and p orbital of oxygen is taking part, and in this bond unhybrid p orbital of sulfur and p orbital of oxygen is taking part. Okay, so as you can see from here that in sp2 hybridized condition, the sulfur atom is having two unhybrid orbitals with half-filled condition of electrons p and d. So this orbital which takes part to form d pi p pi pi bond, and this will form p pi p pi pi bond. Okay students, and here in the case of SO3, central atom is having same hybridization as sp2, and there are three unhybrid orbitals, so one p and two d orbitals. So in this structure, two d pi p pi pi bond will be there and one p pi p pi pi bond. Okay students, thank you very much.